Hello, my name is Reynolds. Welcome to section 2.3, College Algebra. Today we're going to be looking at graphing linear functions. So today we're going to look at the line y equals mx plus b, where m is defined as my slope. And I'm going to give you two definitions of slope. One definition says if I give you a graph, we will use rise over run for a definition. But if I give you 2 points, I'm going to show you today, we're going to do change in y over change in x. So slope is defined as, again, change in y over change in x. It doesn't matter the order that we do those in, just be consistent. We're also going to look at vertical lines having no slope and horizontal lines having zero slope. I'll talk to you about that more in just a minute. So again, if I do slope, we get rise over run. The order that we do these in does not matter as long as you do 0.2 minus 0.1, or in this case, 0.1 minus 0.2. Just be consistent. So looking at this, if I call this point A and this is point B, I could tell you that the slope could be 4 minus a negative 3, doing point A minus point B, negative 1 minus 2, and that should be the same thing as doing point B, negative 3 minus 4 over 2 minus a negative 1. Either way, I'll get the same answer. Negative 7/3 is the solution. So just be consistent when finding your slope. These slides show you that sometimes for the third line here, we've got a horizontal, and you can see that it's horizontal because the y values are equal. So when finding the slope here, if you're doing that y minus y, I'll get divided by some number. 0 divided by some number is 0, and that's actually a good number. But down here in the fourth line, I'll end up with a vertical. And the reason why I'm ending up with a vertical is because it looks like the x values are equal to each other. So if I do 5 minus 3 over the same x value, this is what is undefined. If 0 is under, it's underdefined. It's a quick way to remember. You can't divide by 0. So again, if you have positive slope, you're reading a line like you read a book from left to right. It's going to slant upwards to the right. If you have negative slope, it's going to go down and to the left. If you have slope of 0, then it's a horizontal line. Horizontal lines, again, you can make the letter Z from that. And then if it's vertical, you can write the letter N from the vertical lines. You can use your graphing calculators and see how the slope differs from one graph to the other graph. So I'd graph those and play around with your graphing calculators. Given a point and a slope, we're going to graph some lines and look at the equations. So given a point 3, 2, I'm going to go out to 3, 2. And then this says rise 3 and always run to the right. So rising 3 and running to the right 4. I would do it again, rise 3 and run 4. I'd fill up the graph as much as you can. This one says start at the same point, over 3 up 2, but this time I would throw the negative in the numerator, which means go down and then go to the right. So I'm going to go down 4 units and then to the right 5. And again, I would do that over and over again so you can see the graph filled up. So instead of going down and to the right, you could go up and to the left and find other points as well. Vertical lines, again, have no slope. And that's because you're dividing by 0. So we have a new equation. You cannot write it in the form y equals mx plus b. We'll just say x equals 3. And the reason why is because every point along here, x will always equal 3. So if I go over 3 to the right, the y value will change, but x will always equal 3. Remember, this has no slope. So, and we write vertical lines as x equals a. I don't use the point slope formula, y minus y is equal to slope x minus x very much. The authors of the book do, but I would prefer you not use this definition. I just always go back to slope intercept, y equals mx plus b. I'll show you an example of this. So instead of using this as a scenario, or you can use this if you'd like, my math lab does it as well, but I just go to y equals mx plus b, and I plug in the slope of 4. And now I need an x and a y value. Well, here's my x value in yellow, here's my y value, and I'm just going to plug those in. 2 is equal to 4 times 1 plus b. If I subtract off the 4, I get negative 2. So now I've got all I need to write the equation of a line. I've got slope and y-intercept, so y is equal to 4x minus 2. which means I put a big old dot at -2 and then rise 4 and run 1. The other way to do this is to plot this point, 1, 2, and run your scenario. So that's what this author did. They plotted 1, 2, and ran your slope. But again, notice that the y-intercept really is 0, -2 through this slope-intercept method. For this problem, I also would not use point-slope form. It tells me that it's a horizontal line. So horizontal lines look like the horizon, and they're going to just have they're going to have 0 slope. So I'm just going to plot the point 3, 2, rise 3 and run 2, and I know that it's a horizontal line. And so the equation of this line would be y is equal to whatever the y-coordinate is. And in this case, the y-coordinate is 2. So y equals 2 is the equation. I would not run through point-slope form. So if it's vertical, I would say x equals lines. If it says x equals 5, I draw a vertical line at 5. If it says y is equal to 3, I would draw a horizontal line at 3. Next, we're going to be looking at, if I give you 2 points, how to find the equation of a line. If I give you a graph, you can just count rise over run. But again, I wanted to show you the definition. If I give you 2 points, we can do y minus y over x minus x. It doesn't matter if I do point A minus point B, just stay consistent. So I'm going to do point A minus point B. 4 minus a -1 over -1 minus 3 gives me 5 over -4, which I would write as -5/4, which means go down and always run to the right. So I've got a point. You can use either point you want. Start at -1, 4, and then go down 5 and run 4 and graph that line. So to write some equations, I would use that y equals mx plus b. This is what I've been teaching you. Play around with your calculator on these graphs as well. So the hard part here is looking at standard form of equations. So if I give you ax plus by equals c, this is the third form of a line. So we've got y equals mx plus b, that's called slope-intercept. I don't use point-slope very often, but on occasion I will. So there's point-slope, and then I have standard forms. So please know all 3 forms of the equation of a line. If I give you something in standard form, I'm going to change my definition of slope. My slope is now going to be monkeys wouldn't prefer apples over bananas. And the wouldn't prefer apples is the -a term. So right here, if a is 3, I would say the slope is equal to -3, the opposite of a, over the b term, which is -2. So in this case, I can quickly see, given in standard form, the slope is going to be 3/2. And also I need to find a point. So to find a point, I would use my x-intercepts and my y-intercept rule. To find an x-intercept, you let y be 0. And if you let the term be 0 and divide through by 3, you've got 2, 0. And this is all I need, is a point and slope to graph a line. I'll go find the y-intercept in just a moment, and we'll use that as a checking mechanism. But all I need is a point and slope, which I think I have. I'm going to plot the point 2, 0. And I'm going to use my slope. Monkeys wouldn't prefer apples over bananas, which is 3/2. So rise 3 and run 2. Instead of going up and to the right, I could go down 3 and 2 to the left. Looks like the y-intercept is going to be -3. Let's find out. By plugging in to find a y-intercept, I let x be 0. So if you let this x term be 0 and divide through by -2, we'll get -3. And that's surely what I had before when I did the slope over and over again. You can run the scenario again. Here's a general form of equation. Ax plus by is equal to c. Again, I'm asking you to use monkeys wouldn't prefer apples over bananas as a quick definition to find slope. So this is the same problem almost, but I'm changing the slope. You can run that on your own. Parallel lines have same slope, and perpendicular lines have opposite reciprocal slopes. So if 2 lines are parallel, I know that their slopes are going to be the same, the rise over run. So if I give you something in standard form, we can quickly find out that the slope, I would not spend time solving for y. That takes too long. So the new trick is to do the formula. Monkeys wouldn't prefer apples over bananas. So quickly, the opposite of this number, it's much easier than solving for y anyways. Why wouldn't you want to do monkeys divided by, or monkeys wouldn't prefer apples over bananas? Over here, slope is equal to -a over b. If I give it in standard form, ax plus by is equal to c. So looking at the slope again, -4/6 reduces to -2/3. I can tell quickly without even graphing the two functions that they are parallel. In order to graph these, you might want to solve for y, but you don't have to. You could have used your x-intercepts and your monkeys wouldn't prefer apples over bananas definition. I'll just show you one scenario really quick. To find the x-intercept, you let y be 0. If the y value is 0, you cross that out, because 3 times 0 is 0, and divide through by 2. Plot the point 3, 0, and then use your slope, which remember, we found before that our slope was negative 2/3 in both scenarios. And negative 2/3 means from this point, go down go down 2 and run 3 to the right. Well, instead of going down and to the right, I could go up and to the left. And so you can see that the slope is negative 2/3 for both scenarios. So in this scenario, we're going to find a line that's parallel to this. Again, I would use my definition. Monkeys wouldn't prefer apples over bananas. Here's my a value, there's my b value. So I would say the slope in this case is negative 2/1, which we'll just call that negative 2. If it's parallel slope, then I know it has the exact same slope. So I'm going to use the slope of negative 2. Here's my x and y. You can go to point slope, but I'm going to go to y equals mx plus b. The y value is negative 3, the slope is negative 2, the x value is 2, and I'm going to solve for b by adding 4 to both sides. So I have the y-intercept, now I have the slope, and the equation would be y is equal to negative 2x plus 4. In this case, I want to find perpendicular. Remember, perpendicular symbol is like this, and it's the opposite reciprocal for the slope definition. So they always form 90-degree angles. So I would use opposite reciprocals. Notice that when you multiply them together, their product will be negative 1. And you should get a right angle in here as well. An example of this would be finding the slope of perpendicular lines. So if it's perpendicular, it's going to have opposite slope. So if the slope is negative 4/3, perpendicular slope would be the opposite of negative, which is positive, and then the reciprocal of 4/3 is 3/4. So running the scenario of this, like we did before, I would say monkeys wouldn't prefer apples over bananas. I would locate the slope, in this case the opposite of 1/3, but perpendicular slope would be the reciprocal of that and the opposite of that. So I would use slope of 3, and I have again a point here, so I'd run this scenario y equals mx plus b. The y value is 2, so I'll plug in a 2 for the y. Actually, that's a negative 2. The slope is a 3. The x value is 1, so I'll plug that in here, and I'll solve for b. So negative 2 is equal to 3 plus b, or negative 5 is equal to b. And now I have everything I need to write the equation of a line. Y is equal to negative 3x minus 5. That line is perpendicular. 3x minus 5 is perpendicular to the given line. They have opposite reciprocal slopes. So you can run through some scenarios of multiple choice here. See if you can come up with the answer. Horizontal line containing the point. If it's horizontal, it looks like this, and it's going to be a y equals function, and I can see that the y value is going to be always 9. Finding the slope, I hope you feel comfortable with monkeys wouldn't prefer apples over bananas. You can pick off the slope really quickly by doing the opposite of the first number divided by the second number. So in this case, negative 5/7. That's much faster than spending the time and trying to make a mistake by subtracting off 5x. This is how the books teach it, and getting 7y is equal to negative 5x plus 3, and then dividing each term by 7. It takes a lot of time, and again, there's some mistakes that can be found in here. So I could have found that negative 5/7 by using the definition a lot easier. It doesn't look like any of these are the solution, so I'll change it so that now answer A works. That's all. If you have questions, please feel free to email me.